Hi, this is Tom with Starburst. In this video I'm going to cover Galaxy cluster sizing. So what is a cluster? It is a collection of nodes. As you might know, Starburst Galaxy is built upon the popular open source project named Trino, formerly known as PrestoSQL, which came out of Facebook. It's also known as an MPP engine. So what is an MPP engine? It's a massively parallel processing engine, which basically means the more nodes you add to a cluster, the faster performance is going to get. In Starburst Galaxy, we have clusters based upon t-shirt sizes. So we start with extra small, as you can see on the right hand side, and we go up to 2x large. We also have a free tier as well. So what we advise our customers is to choose the best cluster size based upon your different query types, data volume, and concurrency of your queries. What's nice about Galaxy is you can upsize or downsize clusters at any time without disrupting any existing users or queries. And lastly is clusters are automatically suspended when not in use, saving money. As you can see down here, I have a cluster that's suspended. So what happens is if I have a query that's executed against this cluster, it'll wake up, it'll hold that query, it'll start the cluster, execute that query, and if any more queries come in, if not, there's a certain threshold that you can set, it'll go back into suspend mode. So that's a great way to save a whole bunch of money, especially when you're running in the cloud. So cluster credits. So clusters are billed by credits. We have the concept of a credit per cluster. So as you can see, the right hand side of this image is the extra small is 2 credits, and they go up as you increase the size. We have an extra large and a 2XL large that we can enable upon request. Each cluster is measured and billed to the second, which is pretty much a cloud pattern these days. And also you can upsize and downsize clusters at any time without disrupting users. That's I talked about that before. Also, our current pricing can always be found per credit on our website at starburst.io. So how do you choose the right cluster? We get this question a lot. And so really it's a balance of number of concurrent users with the complexity of the queries along with the size of the data that's processed. So there really isn't just a rule of thumb that somebody could say, I have just, here's a couple of queries I have, can you tell me exactly what cluster size? So really what we encourage our customers to do is benchmark, start with a small cluster and increase as needed to make sure that your SLAs and your budget are met. And we'll kind of go over this in some testing that I did. So keep in mind, larger clusters aren't always faster for smaller, more basic queries. So some people think they need really large clusters for everything, and that's not the case. And what's nice about Galaxy, with a couple of clicks, you can either upsize or downsize, or you can create different clusters as well. So we encourage you to create your own benchmarking spreadsheet to determine which cluster fits your processing needs. And I'll show you an example of that in just a second. And we also suggest multiple clusters for different workload types. And the reason for that is with Galaxy, creating a cluster is just a couple clicks. So then you can see your usage based upon each of those clusters, and you can use that for chargeback to different users as well. You can also have insight into let's say you had 20 reports that you ran, and you have a cluster just dedicated to those 20 reports that run once a day. The rest of the time it's in suspend mode, so it only costs you when you're running those 20 reports. Then at the end of the month, you can actually see how much credits those 20 reports are costing you, or that cluster is costing you for the month. So that's really nice to be able to break the cost out. And then in addition too is different workloads a lot of times have different clusters, so it's not usually one cluster size fits all. So we suggest to our customers is like BI reports, ad hoc, and ETL all get their own different cluster. So here's some testing that I did. I took the industry decision support queries called TPC DS. I had about 70 million rows, and I executed them one at a time. So I did it one at a time in parallel. In this chart here, as you can see, in the spreadsheet here, I ran something called Q21. So I just took a couple of really small, smaller medium queries and a couple large ones. So this Q21 isn't very large, but I ran them in serial. So I would run one and the next one would run after that. So after 5 runs here, at those 5 reports basically, or queries, took 51 seconds. So as you can see, as we go down, we increase the size of the cluster, the seconds go down. But this is kind of interesting here. So we have 36 to 46. So the large actually took longer than a medium. And the reason for that is because there's more coordination that needs to be done, and it's such a small query. And I talked about this before. Sometimes smaller clusters can actually run small queries much quicker. But as you can see, some of these larger queries here, that's Q02, took 294 seconds for all 5 of these to run, and only 68 seconds for large. So what you can see is the total time over here on the right hand side to run these, and then you can see the credits that it cost. So you might be thinking, okay, well, I'm always going to pick the 29 seconds. Well, you might, because it fits within your SLA, your service level agreement. But maybe your service level agreement is maybe having these done under 200 seconds, let's say. So then you would pick a large, and then you would just have to have those would be the credits. So it's kind of a combination between the budget that you have and also the amount of time that you have for your SLAs to run queries. The next thing I did was run each of those queries in parallel. So I took that Q21 query and I ran 5 of them at the exact same time. And I did that for all of these different, all 4 queries here. So as you can see, the extra small ran these all in 498 seconds, and then the large was 87 seconds. So you can see there's a pretty big difference between the cluster sizes in here, and then you could see with the different credits as well. And this is a little bit more real world, where you have a cluster that's running multiple queries at the same time. So let's recap here. So when we talk about cluster sizing, is we recommend to our customers to benchmark each cluster size to fit your needs. You could just do it with a couple clicks of a mouse, and I'll show you right now how easy that is. So I've got a cluster here called AWS East 2. So I'm going to go ahead and start this up. And while this starts, I'm going to come back and go over a couple of these bullet points, and I'll show you how easy it is to resize. So again, start with a smaller cluster, go up from there. Take advantage of suspending clusters as well. So just because you may not want to pick a very large cluster because you're worried about the expense, but we do have the suspension option in there. So after 5 minutes, half hour, whatever it is, set that large cluster, because you're going to need it to run some very large queries. But then it just goes in suspend mode, so you're not worrying about the pricing of it. So it's a different way of thinking of, instead of just having a cluster up 24 hours a day, I only want that cluster up when I need it. Also, create clusters per workload or groups or departments. So ad hoc cluster, ETL cluster, BI report cluster. So different kind of clusters either per workload or groups or departments. We're going to sneak back over here and we can see that this is running. So what I'm going to do here is I'm going to go run a query on this cluster called AWS East. So this just spun up. So I'm going to go ahead and run this query. It takes about 6-7 seconds on the first time it runs, 4 seconds. So I'm going to come in here and edit the cluster. And I'm going to make it a small to, let's just call it a medium. So I'm going to go ahead and hit save, and it's going to ask me, do you want to update the running cluster? And I would click yes. So what it's doing right now, it's bringing up another cluster in the background, but I can still come in here and run queries all day long. It's no big deal. It doesn't affect my end users running queries. But once the new cluster is up, any new queries I execute from either within the query editor or any kind of BI tool or any other tool that goes through JDBC or ODBC, they're going to go against the new cluster when it comes up. So it'll be, if I'm upgrading, going to a medium, obviously those queries are going to be faster for those end users. And then any queries I have running will be, we'll make sure that they complete on the old cluster, and then it'll be terminated. Again, this is all seamless to the end user. They never even see these clusters being upgraded. And so, and lastly is, contact us if you have any questions, or if you want more in-depth proof of concepts for Galaxy. We have some customers that have a lot of different workloads and they have a lot of questions. So we encourage you just to contact us with any of your questions. And on the right-hand side here, I just have our website. You can come in here and try Galaxy for $500 free credits. And then you can run queries. And, again, contact us if you have any questions. Thanks for your time.